Hey everyone, this is our second lesson starting on this cluster for geometry support or MCAS intervention. These are the standards we're focused on, and today our objective is going to be to apply our exponent properties to help us simplify expressions. So whenever we see exponents, we want to be aware of these properties and be able to apply them. So let's jump right in. On this first one, I'm going to do the example of us together. When we have, here it says a product, in other words, we're multiplying. What we want to be able to do is rewrite this just as one term, like a coefficient, an x, and a single exponent. So we want to be able to combine these things. So if I break this down first, I see we're multiplying a 2 times a 3. So our coefficients, our numbers, are just going to turn into 2 times 3, which is 6. So that's pretty straightforward. Next are our x's. We have x to the 5th and x squared. So this means there are 5 x's being multiplied together here. 5 x's being multiplied, aka x times x times x times x times x. That's 5 of them. And then from the second term, we have 2 x's. So that's like x times x. So if I were to count in total how many we had multiplied together, because we want to find that out for our final answer, there's 1, 2, 3, 4, 5 x's from the first bit, 2 x's from the second bit, 5, 2, for a total of 7. So when we multiply, when we're multiplying variables with exponents, we add up their exponents. So it's going to be 5 plus 2 gives us 7. So if I want to show that here, I might write 5 plus 2, and then rewrite my answer one more time. 6x to the 7th. That would be our final answer. So we multiplied our coefficients, and then we added up our exponents because we had a total of 7 x's that were being multiplied together here. Okay, so next you should pause the video, try out this example on your own, then we'll come back and review it. So pause it, we'll come back in a second. Hopefully you paused this, we're going to try it out together. This one had a little bit of a different thing in it. Here the coefficients are still pretty easy. 5 and 2, we can multiply those. That gives us 10 as our coefficient. Now for the variables, we have x to the 8th and x to the negative 1. So if I applied my rule from before, which was just add the exponents, that's what we did over here. If I tried that here, I would get 8 plus negative 1, which we could do, and that would give us 10x to the 7th. So that's a correct answer. I want to point out here while we're here that this negative 1 is, we can interpret that. So if a positive exponent is how many times we multiplied, so here we multiplied 8 x's together. So x times x times x times x times x times x times x, x. 1, 2, 3, 4, 5, 6, 7, 8. So that's that first term written out. The negative exponent means we divided out one exponent, or it's the same as 1 over x. So whenever you see a negative exponent, it means divide that thing that many times, or write it as 1 over that thing. Then we see here, if we multiplied, we would be able to cross out one of the x's because we have 1 multiplied, 1 divided, leaving us with a total of 1, 2, 3, 4, 5, 6, 7 x's. 7 x's. So however you want to see it, whether you want to see it written out as a bunch of x's, or you just want to apply our rule, which was add our exponents. So 8 plus negative 1 gives us the exponent. Great. Something similar here. In the second one, now it says power to power, so we're going to have an exponent raised to an exponent. Here we have this quantity, 2x to the 3rd, and it's raised to the 4th power. So just like before, I'm going to write this out. This means it's being multiplied by itself 4 times. 4 times, so it's going to be 2x to the 3rd times 2x to the 3rd times 2x to the 3rd times 2x to the 3rd. That quantity that was inside multiplied by itself 1, 2, 3, 4 times. If I want to figure out how many are in total, to get my coefficients first, I could look at my expanded term 2 times 2 times 2. Basically, that's 2 times itself 4 times. So that's going to be 2 to the 4th power. We'll simplify that in a second. And then for the x's, well, that's x to the 3rd to the 4th power. In other words, x to the 3rd multiplied by itself 3 times. Now, you may recognize this. There's a rule to apply here. When we have two powers, a power raised to a power, we rewrite that as the product of them. So 2 to the 4th times x to the 3 times 4, which is 12. Multiplying them makes sense here because we had 1, 2, 3, 4 groups of 3x's. So in total, we had 12 x's. You could also think about adding them 4 times, like 3 plus 3 plus 3 plus 3. But basically, in short, when we have a power to a power, we multiply exponents. Two to the 4th, 2 times 2 is 8, times 2 is 16, times 2 is 30. I'm going to do that wrong. 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is going to be 16x to the 12th would be our final answer. So here we have power to powers, which means we take both anything underneath it and we raise it to the 4th power. So 2 to the 4th and then 3x to the 4th. We have two exponents, we multiply. Try out this example on your own. Again, try and pause this, think through it first. Then we'll come back together. So hopefully you've tried it. If I go right in, I see, I have a power to a power. So I'm going to take that 2, or I could expand it out as x to the 4th times 3x to the 4th. Basically, I see there's a 3 times 3, so 3 squared, and an x to the 4th squared. Let me highlight those so you can see. The 3 times 3 gives us a 3 squared, and the, let's go dark, but x to the 4th times x to the 4th gives us the x to the 4th squared. And that's the same as 9x to the, that's 2 groups of 4, which is 8, or 2 times 4. 4 times 2 gives us 9x to the 8th. So when we have this power to power property, basically we're saying raise everything in the parentheses to the 2nd power, and that involves multiplying exponents. So it's going to be 9x to the 8th. Okay, negative powers are pretty straightforward. We talked about them briefly already. They basically mean divide by it that many times. Basically means divide by the quantity. So here, instead of having x multiplied by itself 4 times, it's saying take x and divide it out 4 times. So the way we write that is 1 over x to the 4th. So whenever you have a negative exponent, another way to think of it is you could just flip it. Imagine having this as like x to the 4th over 1. We flipped it upside down to get 1 over x to the 4th. We'll do the same thing for the y. 1 over y squared. If I wanted to rewrite that just as one fraction, I could write it as 1 over x to the 4th y squared. All right, let's try it over here. Negative powers, same thing. Again, you should try this first actually, so pause the video, try it out, then we'll come back together. So hopefully you've tried this out. I see x to the negative 1/5. That means divide by x 5 times, so I'm going to write 1 over x to the 5th. And then y to the 6th, that's still just y to the 6th. It's not negative, it's just a normal power. And then, again, if we're multiplying something by a fraction, I can think of them both as fractions, and then just multiply them straight across. So this would be y to the 6th over x to the 5th. All right, quotient of powers, last one. So we've talked about so far when we multiply things with exponents, that's right here, multiply, and that meant we add exponents. We talked about exponents of exponents, and that meant we multiplied exponents. When we had negative exponents, we divided. The last one is going to be when we're dividing. So if we divide, this is going to be the inverse of multiplication. So up here, multiplying left us to add exponents. So dividing them is going to mean subtract. All right. Now I have to be careful here. We got to match up only things that are alike. So I see an x to the 5th and an x to the 8th. If I write this using our rule, that's going to be x to the 5th minus 8, because I'm subtracting the ones that are being divided. Thinking of this as we did before, it's like saying x to the 5th on top, which is 5 x's multiplied together, 1, 2, 3, 4, 5. And on bottom there are 8 being divided, 1, 2, 3, 4, 6, 7, 8. I can cancel some of these out because they're inverse operations, multiplying and dividing. If I cancel some of these, I could cancel up to 5 of them. So in other words, we had 8 on bottom, and I had 5 on top, and I could take those 5 pairs away, and I'm just left with 3. So that's why subtracting makes sense here, because we're going to get left over 3. For the y's, I can do the same thing. It'll be y to the 7th minus 2. 7 on top, 2 on bottom. This is going to give me x to the negative 3 and y to the 5th. And then I still see there's a negative exponent here I want to take care of. I don't like that. I want to rewrite it as Sorry about that. If I want to fix this negative exponent is where we left off, I would just fix that by rewriting it as a division. So the y to the 5th is still on top. I'm going to rewrite that as a 1 over x to the 3rd. And then multiply those fractions across like we did before. Y to the 5th, keep my colors consistent. Y to the 5th on top, x to the 3rd on bottom. So that would be the simplest form of that. There's one more example here where you can apply this rule. Basically, when we have a quotient, when we're dividing, we subtract. Pause it first, try this out, and then come back and check it. So hopefully you pause this. I see here there's 2 variables we're working with. We have x's and we have y's. X's I can rewrite x to the 3rd. My rule is to subtract 4 when we're dividing. And my y's, x's are in blue, x is in blue. My y's, it's going to be y to the 2, that's my top bit, minus, on bottom, this is like a y to the 1. So minus y to the 1, or just minus 1. And I'll rewrite this. That's x to the negative 1. Y to the 2 minus 1 is just 1. Again, I don't like this negative exponent. I want to rewrite it. Oops, don't like that negative exponent. I want to rewrite it. y to the 1. So the y stays on top. I'm going to rewrite that as a 1 over x. And then again, think of them both as fractions. Multiply, get y over x. All right, so these are 4 different properties, and there are a lot of them. In general, though, we can just remember the rules when we're multiplying exponents, when we're finding the product of 2 terms, we can add the exponents. So when we had like x to the 5th here and x squared, we added them up because that's a total of 7 x's being multiplied together. When we have a power to a power, we multiplied. So here we had x to the 3rd all raised to the 4th power. That meant there were 4 groups of 3, or a total of 12 x's. When we had negative powers, so anytime there's a negative, that's not considered simple. So in the M class, they're going to expect you to be able to see it as 1 over that. So whenever you have a negative exponent, you can divide by it. So put it 1 over. And then lastly, when we're dividing exponents, we did the inverse of multiplying. So instead of adding our exponents, we're subtracting them. So if we had 5x's being multiplied, for example, here, and 8 being divided, that's 5 take away 8, left us with -3, or 3 being divided. Same thing with y's. We had 7 y's multiplied, 2 divided. That means there were 5 take away 2, or sorry, there were 7 take away 2, 7 take away 2, or 5 y's altogether being multiplied. All right, you should be able to apply these properties down here. There's going to be some interesting things that show up. You should talk to your intervention teacher about them. On the back, it's a total of 10 problems to practice simplifying. 12 problems to practice simplifying. And then down here, this is your mastery, showing that like I've done the practice, I'm ready to see this. If when I see it on the MCAS, I'll be able to master it. So if it takes you some time to get through these, that's fine, but you should do all the practice before attempting the mastery to show that you did it. All right, see you next time.